Hi, I'm Naz. I'm the CEO and founder of Rebel and the author of Developer Life and the maintainer of the Rebel 2E crates. I believe that open source comes from an open heart and the joy of coding. In today's video, I'm going to go over a few examples covering Rust declarative macros. I'm a huge fan of macros. They make a ton of sense when used appropriately, and sometimes they can lead to quite a big mess if they're used incorrectly, like, for example, to try and be clever and bypass the compiler type system checks and things like that. I've seen some awful stuff with macros, but yeah, when used properly, I think they're an incredible way to enhance the expressiveness of Rust. And when tied to particular use cases you might have, it can lead to some pretty fantastic ergonomics in terms of API design. And also, like, I discussed this in, I did a couple other videos on the type state pattern and the new type pattern, and they can be used to make APIs kind of like really hard to use in the wrong way. So with in today's video, we're going to cover 4 examples of declarative macros. I have a massive write-up on Developer Life on procedural macros. Where is it? And like, I think, let's see, okay. And since I wrote this, like, what the heck is going on here? There we go. Since I wrote this, the Rebel 2E crate had, it's the Rebel 2E crate, just as background, is just a crate from the ground up that's used to build text user interface applications. It has all kinds of stuff like async readline, choose, which allows essentially simple interaction to happen, and full-blown what I call 2E or full screen or full terminal experiences, and a blend of all of those 3. So that's in here. I've been rewriting this whole thing. It's been around for, I don't know, since 2002, I think, and pretty much in the there's a massive refactor that I did rewrite, and so I haven't released a new version yet, but it's going to be totally different than it was. I mean, in many ways it'll be the same, but in many other ways it'll be very different. So it's going to be good. And this video and a bunch of others recently have been derived from this massive rewrite, the experience of doing this massive rewrite. So yeah. So anyway, so I used to use a lot of procedural macros in the Rebel 2E crate, and there's benefits and costs to using procedural macros. So one of the big things was you have really complicated crate structures. So in order to create a procedural macro, you have to create an intermediate crate, which sucks. Declared macros are great. You can put them in whatever crate you're writing your code in. Procedural macros are obviously sort of boundless, limitless in expressivity to an extent. You can like make your own domain-specific language, but I actually decided to remove procedural macros from the Rebel 2E crate because I was able to actually finagle declarative macros to do what I needed, and that's what largely this video is also about. So I'm going to show 4 things that I did, 4 patterns that I see coming up over and over again as I kind of migrated away from procedural macros for my particular use case for Rebel Open Core. And yeah, so with that, it'll be fun. There's actually macros are great, and I mean, this is kind of like how to take declarative macros and then like do really awesome things with them, so that it kind of like start encroaching on the sort of realm of procedural macros. Not really, but it kind of seems that way sometimes. So, or I mean, with these examples, you might see like, wait, what? You can do this with declarative macros, that kind of thing. So let's see. So let's get started with our first example. This one is going to be, let's open a terminal. Let's see. Okay, so we're going to do cardinal new lib rust decl macros. And let's open this in Code Insiders. All right, so here we have it. Let's exit this. Get rid of that. All right, cool. So The first example actually is going to be something that one of the use cases I have is that in the Drupal 2 crates I need to describe color. Color can be described in RGB values and ANSI index values. It's a whole other way for ANSI colors to be described. It's an index into an array of a byte, so 0 to 255. And then there could be other ways of expressing colors. There's also this requirement that they're predefined colors. So like for example, named colors that are part of the palette. You can imagine coming up with your own theme where you might want to like do interesting things with expressing colors. So in this example, I'm going to give the let's see, go over this thing. It's called 2 color, and I'm not gonna I'm gonna have links to this actual code in the description of the video. But for what we're trying to do, like the syntax we're trying to get at is that, let's see, wow, this is like a really big file. Okay, it's not in here. But yeah, I'll actually it's one of these tests basically. Is that let's see, is there any tests here? So the syntax we want, oh, actually colors can also be in hex. So you know what, this is too complicated. So I'm just gonna create sort of a version of this from scratch so we can see, like, how to build up. And you could actually reference the source code to be like, okay, how is it done in the sort of real world in production, so to speak. So let us add a file. We're going to call it example1, and we're going to create an example1 file, and let's see, there we go. And in this example, we are going to, let's say we want to do this. We want expected syntax. So this is kind of like, it's a little bit test-driven, development-y. So let's say I want like RGB values, and I want to be able to describe those RGB. So I want to say let R, and the reason I'm doing this way and not using usize is because of the type state pattern. I have a nice video on that, or new type pattern, sorry, G. So I want G and B, and then I want to be able to create color out of it by doing something like this. Let's just say color RGB. But also I might want other colors, like actually you can do these. So this is one example of what we want. Another example is I want like a named color. So I want to do something like let color is, let's say, pink, and then I want to do some assertions. I'm not actually, let's see what pink would be. 195. It's handy to have these numbers. So we can say assert EQ. Nope, that's not right. 195, 106, and okay, something along these lines. So let's say that this is sort of what we want at the end. So we're going to sort of start with this. Obviously it doesn't compile, but we're going to make something that gets us there. So I have this whole video on like the new type pattern, which is really awesome. You essentially wrap a primitive type in another type, and then that allows a lot of expressiveness and also disambiguation between one and other, this and that. So for example, these are all, if I said that they were all usizes, I wouldn't be able to tell an R from a G from a B, which is not really taking full advantage of the type system. So here we can say it just wraps a usize. Actually, I can, because I know that it's RGB, I can just say U8, right? Because it's not going to go. So here we can say G is U8 and B is U8. So here we have RGB, right? So what we're doing is that, so that goes, this works, yay. Actually, maybe we can do this as well. So I know I'm putting everything in like a single test, but actually let's separate these. So let's say expected syntax. This is expected syntax from RGB. And then we're going to have another one where we say expected syntax from named colors. So color, and finally we can do let's see, another test for the type state. Oh no, sorry, I keep saying type state. New type works. So this one, new types work. So here we can say like something like that, and assert that like that. And I'm leaving it as 0. Like if you wanted to do more complicated stuff, you could implement deref actually. So you can say implement deref for R, and you can do something like this. But you know, and then you don't have to say r.0 anymore. Now you can put a star and dereference it that way. I don't know which is clear. Actually, you know what? I like this syntax much better, but I want to focus on the macros, so I'm just going to kind of skip the deref implementations. But yeah, just know that you can do that. So 0. Okay, so now we have one test working, so this works, and that's great. So now we got to make the color macro. So I'm actually going to start with a simple one, the RGB, because why not? So here we can create macro export and macro rules, which is awesome. Let's see. Name identifier. So let's just don't know what this. That's what. I don't know what this is. This is weird. So here, let's just do this. So we have an expression that basically we're saying that go look for a pattern like this, where you have 3 expressions which are comma delimited, and they're not going to be identifiers. So we can actually like, let's see, macro exports, RGB, what is wrong with this? Actually, let me comment this test out for now. What is the problem? Oh, right. Let us do this. Let us put this up on the top. I guess I ended up writing the tests first. And we don't have a color struct. That would help to have one of those. So we can say struct color. This is fun now. It's an R, G, and a B. So this is kind of like I'm building up. And, you know, we can put pub here, but for this example, I'm only going to be using this file in this module, so it doesn't really matter. So here I don't have to name like R, G, and B. It's pointless because the type system is going to take care of that for me, because I cannot mix up G and B. This is one of the nice things about using the new type pattern. So here I don't have to do something complicated. I can just do something simple like get rid of all of these, and just like that, and we have a color. And what is the problem? Is it RGB? Oh, did I pass them in wrong? No, RGB. These are positionally correct. Let's see what's going on. Expected R found you at, oh, my bad. I don't know where these .zeros came from. Okay, there we go. It's as simple as that. And so now, well, this is not working anymore because color that comes back doesn't have an R, G, or a B, but what it does have is 0, 1, and 2. Oops. What's wrong here now? Ah, yes, of course. So now I gotta add some, it's saying it can't, so usually you have to do like this, debug partially queue, so that the tests will pass, because you know you're probably asserting that something is something. And then now it's complaining because which is correct actually. What it's saying is that, hey, you can't compare, this zeroth item of this tuple with 1. This is what type? This is not the right type. I'm expecting a red, a green, and a blue. So far this has still been like type state. Like this is the benefit of using new type, and I keep saying type state. This is the benefit of using new type pattern. So there you go. There's an example of like, okay, we got our new types working. We got, let's say, let's run this test. Yay. Also, you can use Bacon. Bacon is a really good tool. Yeah, there's all the tests are passing, so that's great. Also I use next test, which is nice. It's just much faster than cargo test, but it doesn't run doc test. So yeah, it's useful. Okay, so I'll color it. It's fine. Essentially, because it's just being used in this test, it's fine. It's saying that it's not really used anywhere. Okay, so we're gonna ignore these Clippy's dead code, or like it's okay. It's okay to have dead code, so we can just say allow dead code. I don't know if this will. Wow, that's cool. So propagate it to all the files in that source tree. That's great. Okay, so okay, so now if we run Bacon, it'll look more. Yay, it's working. And that was Bacon with next test. Next test is fantastic. Okay. So now that we've handled the use case of we can give RGB values which are strongly typed to create a color. What about named colors? Like, how does that work? What if I want pink? Like, I don't want to type, remember, R and G and B values for pink. I want this to be a thing. So here what we can do is, so macros, you can think of it as like recursive code. Like, you want to put the most specific stuff at the top and the least specific stuff on the bottom. And usually base cases in terms of recursion goes on the top. So you can actually have macros call themselves, and then you can even have helper macros. There's all kinds of interesting patterns that allow you to sort of enhance the expressiveness of this thing. But this is the most sort of basic example of this. So if you want to match on like pink, you want to make that like one of the first things that the macro is going to match against. So if you put it here and you say, I want actually literally just the expression pink, like the literal pink. So you want to say something like, if you see, you're telling this macro, you're saying if you see PINK in that sequence, then go ahead and make a color which has these values. So something along those lines. Of course, it's not going to work because it has to be an R, it has to be a G, it has to be a B. And then something along these lines. So this is gonna match. Oh, sorry. We should have done this 0, 1, 2, and we can just say R. And then we can do G, and we can do B. Something along those lines, and yay, the test pass. Okay. So this is our first example where we've done like, okay, the pink color, so when the macro, you can see when it says color RGB, the first thing it does is that it goes into the color macro and says, okay, is it pink? Nope. Is it matching this thing? One expression followed by another expression followed by the next expression? Yes. Okay, then we're gonna return this thing. So that's how roughly the evaluation works. So for example, if you wanted other colors, like let's say, this is a good one. Lizard green, what a cool name. I'm a Porsche nut, so this is one of the Porsche colors. Let's see, lizard green usually comes in there. Crazy sports cars, the GT models and stuff like that. Okay, so lizard green, we got 20 whatever. So here we can say 20 G and B. Okay. So now that we've said lizard green, you'll notice all the other tests still work because it's saying, okay, look for pink. It found pink. Yay. This one goes, okay, look for RGB. it goes, okay, that's not pink, that's not lizard green, that's this thing, and it matches. So wonderful. And so named color, we can do something like this, where no surprise what's happening here, and this should just work. Excellent. All right, so that is like a very gentle sort of first example to kind of get into this notion of specificity in macro matching, where if you want the tokens that you pass the macro, like the specificity matters, the order in which you write this matters. And we'll see how we're going to fully exploit that in there's basically 4 examples in this live coding video, but this is the first one. So another thing I want to mention is that what are these, like EXPR, like what if I put ident here? Is that going to break everything? So if I put ident here, let's see. Look at that, it didn't break. It just so happens that the way we set up the macro here, ident also worked. It's because I created R. So for example, if I inline them, so I'm going to show you this not working. So here, if I inline it, I'm going to break it, because what this is saying is that, oh no, this is unexpected token, because I'm expecting an identifier. This is not an identifier. This is actually an expression. So here I can do like, oh, okay, I see. If I want identifiers, then I should do this thing, and you can do expression. Why didn't I just, let's say expression. So with expressions, if I put R of 1 here, notice that works, because an expression, like this is an expression, and this is also an expression. So an expression is a more sort of generified, if you want to think of it this way. So if I do, this is not very good syntax, but you can do stuff like this. These are identifiers, right? These are ident. Actually, that's not ident. This is ident. And you can say this is an expression. There you go. So it's slightly more annotated, but you kind of get the idea, where we have like a distinction, and we'll play with that as well. What are idents, what are expressions, and what are, again, more specific token matchers. And then there's another one called TT and TY, where those are even more sort of, TT is the most generic. It'll match any token. TY will match types. Ident matches identifiers. EXPR matches expressions. You can even do block, where it'll match anything that's within curly braces. So yeah, there's a lot of power. It just requires a tremendous amount of imagination and creativity to sort of work within the constraints of what are provided with macro rules to make them really expressive and really powerful. So with that, that ends example 1, and then we'll start up with example 2 next, which is going to be a little bit more complicated. And we're going to be using like these tokens. So in our next example, we're going to actually create a macro that uses that TT, those token, the token. Actually, I wonder what the TT stands for. What does TT stand? I think it's token type, but let's see. Oh, token tree, that makes a lot of sense. Okay, so it represents a single token or a delimited sequence of tokens. Makes sense. So essentially, it's everything that's input into that macro ends up in the token tree. So what we're going to do is essentially recursively call a macro and leverage this token tree thing. So we're going to make a macro. We're going to essentially match some tokens, do something with it. Whatever we can't match, we then will apply, basically recursively call the same macro with the remainder of the tokens. So whatever tokens we've consumed, we do something with them, and whatever we haven't consumed, we take the remainder and we call the macro again, the same macro, until there aren't any tokens to consume anymore. So that's going to be example 2. And that's a little bit more complicated, but it allows for much more interesting syntax. So before actually getting into like writing the macro, let's look at what the syntax, this is the expected syntax that we want. So in this example, I'm going to be using, so in the first example, we made color. So in this example, we want to use something called style. And so the style is going to be things like foreground color, background color, and other attributes like bold, italic, and underlined. So that's essentially going to be what our expected syntax is. And actually, let me do this. Pub mod. Oh, sorry, puppies. Example 1. Because we're going to actually now use these pub. Example 2. So let's do this. Okay. So these, let's make them public because I'm going to be needing them in this next example because it's going to be built on top of the color macro and the color structs that we've made. These don't need to be pub, they're already pub when you say macro export. They get exported at the crate level. So like you can't make, like you can't pull it in from ex_1 module, which is kind of interesting. Okay, so let's see. Here what we want to do is, the expected syntax is we want a color to be like, you know, the color pink, which is, that's fine. Actually, what happened here? So let's do this. Actually, now I'm going to make a CFG test because just easier that way. And let's do this. Oops, what the heck? Okay, so here we have a color. What is the problem here? Oh, who cares? Actually, let's do this. Allow unused imports. Okay. Let's see. Cannot find function. Oh, right, because now it's basically I have to say use create or something. Actually, why don't I just do this? Use. Huh, it doesn't make any sense. Cannot find function. It's inaccessible. Wonder why. I think I have to explicitly specify like this RGB and color. No? Oh. What's the problem here? Oh, I think I know what the problem is. Okay. So because we're going to be using it outside, we need to do this. Basically make all the did that fix the problem? Consider importing the tuple struct using use create color. Okay. I think it's I think this is the issue. Basically, I couldn't find it because so what happens is when I re-exported it, I had to clean up the imports. But anyway, so I wonder why. And also, because so if you look at how this macro gets expanded, it's not intuitive what just happened. So basically, either I put these use statements here. So I could do this. I could say use create, let's say, color, something like that. And then I don't have to do all of this. Like this could go away. Just notice the errors went away because when you expand this macro, this is a, let's see, how do you do this? Expand this one. No? Oh, because it's a test. Anyway, so basic, let's see if we do. So essentially it expands it to color R, G, and B, and in this scope, none of these have been imported. So what I have to do is essentially do the imports here. So I can say use create color R, G, and B, and then I can teach this, for example. And I think this is problematic because this is like inline, I think. So let's see if I do super. No. I think in order to fix this, I have to do a curly braces and then say create. Yeah, that works. So I guess this is fine. I guess it is what it is. We can actually do this now because now that we're using these macros in other modules, we can't just assume that all of these dependent structs have been imported. So now things will work. So that was a bit of complication that happens with imports when you're doing when you're using macros, because when they expand, they're expanding where your cursor is. Let's say the block that you're in. And if that block, like essentially this macro will go away and it will be replaced by this code. So notice it replaced it with this code, and that's why it worked. So anyway, yeah. Okay, so here, where were we? Let's go back to our expected syntax. So we have a color, and this is from the first experiment. So the new thing that I want to do here is that I would like to apply that color to a style, and a style can be something like it can have like let's say bold, italic, and underline. So bold, italic, underline, foreground, and background color. So here let's do this. We can say let style equals, and I haven't made this style macro. This is just me making stuff up syntactically. But this is the expected syntax. We want bold, italic, underline, and then we want foreground color. And the foreground color we want to specify as a block, and the background color we want to specify as a block. And so here we can say, let's say foreground color, background color. So I want something like FG and BG, something along those lines. Let's just take this as an example. So the style macro is the thing that will be built in this example. So let's see. Okay, I'll do that later. There's another one beyond this. So okay, so in order for this to work, actually, this is where a couple of things, two new patterns are going to be introduced. One is using the token tree and how to kind of take items off of the token tree and then pass the remainder of the tokens in that tree to the same macro or a different macro. So, and if it's the same macro, then it's recursive. So then there has to be a way to stop the recursion. So that's generally the two things we're going to be playing with. So with that, let's make a couple of structs. So we need a struct for the style, and the style will actually, I'm just gonna, because I know I'm going to be running into this later anyway, might as well just do this now. So the struct, we're going to have the same, let's see, so we need, actually, I wonder why this is strange. I don't like this, something is, off about this inline suggest font family. Oh, I think this is the problem. The inline suggestions were in a very strange font. That's why they looked funny. So I just got rid of it. Okay. So here we want to do essentially something along these lines, right? We have bold, italic, underline. The struct is going to hold more than one of these style elements. And then here we want to say, let's see, should it be optional? That is a thing, something to think about. Let's see, should it be optional? Yeah, because I can have a style where I don't specify a color. Sure, let's make it optional. Okay, so so these are not optional because they're Boolean, and by default, I'm just gonna make them false. So I can give a default. If you want, we can explicitly implement the default trait. So we can say something like impl default for style and false, false, false. And it's going to say, you know what, why are you doing this? This is exactly what derive does. So let's go with that. Okay. So the reason we can get away with this is because we don't need basically like we could do something like this option and then what? Well, we don't have a bold type or italic type. We could do that. We could do the new type, and we can say pub struct bold. You know, but this is a bit. We could do this actually. This is the thing. So then we could actually, let's see. Oops, where is this? We could do something like that. And then here we can say option bold. I mean, we could do this. Italic and option. Anyway, we could do this. And then the default, sure, why not? Let's do this. Why not? So now, as a default, will be that it's a lot more code. And for an example, like it's a bit of a trade-off between like readability and like making it real, good. So anyway, so let's do this. So basically, our style has bold, italic, underline, which are all optional. Foreground, background color, which are also optional. So let's just do this, and here we can say foreground color, background color, and this one will be instead of FG, let's call it pink, and let's call this lizard green, and here we can just say pink, and this is, I don't even want to know what this looks like. I don't think it'll be readable, lizard green, but that's okay. It's just an example. Okay, so here we go. Syntax is bold, italic, underline. So in the presence of this let's say token bold, you can imagine like this macro will create a new style, and it'll walk through these things in the token tree that it sees, and it's going to chunk them up based on the rules we give it, and then it's going to start like assembling a style, and then when it's done, it'll return it. So we have a style macro, but that's not the only thing we need. We actually need another thing in addition to this, and that's going to be the, actually let's do the macro here. So this is kind of like the building blocks. So we need two macros, believe it or not. We need a macro export, and one macro is going to be the style macro. And another one is going to be macro export. This is going to be macro rules. This one is going to be apply style. So if we want to be really explicit, let's do this. Let's say new style. So new style, this means that you're, okay, this macro is going to make a new style struct, and then it will rely on this thing to get the rest of the work done. So let's, so one of the first things we're going to do is now we're going to use this token tree thing. So we're going to say this is going to be all So here we're saying, let's just do the, actually, would this work? Match all. No, not really. Well, maybe. Actually, let's see if this works. Huh, interesting. This is Copilot suggesting something. Okay, let's see if this. I'm probably gonna regret not deleting that, but let's see. So we have a bunch of imports. We make a new style, and then see this thing. It just repeats. So for as many of these tokens there are in the token tree, it will call this repeatedly, which is probably why this doesn't work. So unsurprisingly, let's just delete this. Okay, so what we want is that that's kind of like the basic sort of setup. And then we need, now I regret having deleted that, say macro export. And here we have macro rules, and then we have apply style. Okay, so here what we're gonna do is, let's see, let's do this. Basically, it's placeholder for nothing. So here, there's going to be a to do. Okay, so in the new style, the first thing we need is we need to create a new style, and then we need to return that style, which is the easy part. But in the middle, we're going to essentially call this apply style macro. And remember, the apply style macro gets promoted to the top level crate. That's what macro export does. So I can't import it as create ex2. It doesn't work this way. That's not right. It's going to be like, that's not going to work. Let's see, apply style, something like style. And the remainder, that's not going to work. It's like I can't find it. That's not a thing. So there you go. Okay. So here what we're saying is that make a new style. So when this new style macro expands, it's going to make a new style. Then it's going to call this other macro called apply style. It's a helper macro. And that's going to actually be the recursive one. And then it's going to be given the style that was created. And essentially, all the tokens from here are getting passed through into apply style. So if we say like this here, like it's a no-op, but notice everything compiled. So that's pretty cool. And here we're gonna, it's whining about the mute. It doesn't know. So we're gonna say allow unused mute. Oops, what the heck? Okay, so allow, okay, it's alligator, that'll silence that warning. Okay, so now, actually, didn't I say, oh, right. I think this is allow unused variables. Let's put them all in there. Unused variables, unused mute. That way I don't have to do it. And that won't apply to tests because this is a this CFG, whatever this feature flag. This is basically conditionally compiled only for tests, and this is not a test. So anyway, we would have to basically put all this here. Where did it go? Something like that. So. And then this is applied to, you know, all the tests in that block. So anyway. Okay, actually, I wonder why I even had a CFG test, because I can just do it here at the top level. That's not a big deal. Okay. Anyway, but because it's still a test, it's fine. You know what? I'm just gonna move on. Okay. These errors will go. Our warnings are gonna go away in a minute anyway. Okay, so so we have new style, and now we're going to recursively call apply style. So essentially, we just handed off all the tokens to this macro. All we did here is that, okay, let me make a new style. I'm going to take everything that was passed to me and I'm going to hand it to this thing. And then when it all comes back, I'm just going to return the style. So all the logic, so to speak, is happening here. So here, what we're going to do is that instead of saying all, what we're going to say is that, okay, the first token is going to be, we know from here, is going to be a style. And then then I'm going to say, okay, the remainder of the tokens are going to be something like, let's see, where's bold? Yeah, so let's see, something like, so I'm going to say something like, all right, the first thing is going to be the style, and then I'm going to have the word, what is it? Like, let's just say bold. And then there's going to be a bunch of tokens after that. And those I'm going to, instead of saying all, I'm going to say these are the remaining tokens, sort of the remainder. Because I've basically pulled two of the tokens out, which is this ident that was passed, and I've also pulled out bold. So bold is gone from this token tree. Because remember now, this whole token tree gets passed to this macro, which then turns around, adds style, and then passes. So now this is the token tree for this macro. So it basically essentially took everything in here and then added style at the front of it. So here we're pulling out style, and then we're pulling out bold, and we're saying that whatever's remaining, and we're going to see that here, we're going to say, so we're going to say, okay, if you see this, then go ahead and set the bold attribute of style, which is created here, to this some value. And then we're just going to say, go ahead and recursively call yourself, and then we've basically pulled bold out of the token tree, and then now we reintroduce style into the token tree along with whatever was left. So in other words, from the very beginning, we called new style and we passed it all of this stuff. Then new style injected a new token and then passed all of that stuff to apply style. So bold catches it, removes bold, so this is gone now. And the remainder of it, like italic and all that stuff, is now passed to itself, but it's now injected style again. So essentially, we're going to repeat this recursively until. So let's see. Let me just copy this because this is like that. And here we're going to do like, okay, if it's italic, then I'm going to say italic. And then what else we got? Underline. Let's do underline. Oops. Let's do underline. So if it's underline, we can do underline, and then we have this FG, BG. So those are the, like, whatever, like some other things we got to match for. So so here we can say something like, let's just modify this. So we can say, okay, so I'm going to call like whatever, like I've consumed bold, italic, underline. Now I'm looking for FG. So I'm going to say I'm looking for FG color. But for FG color, this is no longer like a symbol. So like underline was just consumed because that's what we matched against. But FG color is a little bit more complicated. It's FG color colon something, right? So what is that colon something? So here I'm going to say it's for FG color, we're going to use block. So whatever you pass to FG color has to be a block. And because FG, so the literal word FG color is this stuff. And then let's see, we have to say, let me do this. Then I have to say color block. So essentially, I'm just calling it C. So this is a little bit strange syntax. So FG color matches this thing, and then whatever's after it will be matched by this, which is going to be a block, and we can reference that block with $C. Okay. And then whatever tokens are remaining, they get like we'll pass them along because we'll see. So so the way it knows is that whatever you consumed is it's like for example here, like we're gonna essentially eat FG color $C, and then when we call it again, like because we've kind of like in this signature we've said that this is no longer part of the token tree, because if you match against it, it removes it from here. And so that's kind of like how this magic works. It's pretty awesome. There's like a flow to it once you get sort of going, but it's not that intuitive to get started. So so let's see. So essentially now, oops, what is this? So we're saying that, okay, if you give me an FG color called $C, I'm just going to assume that it's not wrapped in a sum. I'm going to wrap it in a sum. I'm going to set it to FG color, the field, where'd it go? This one. And then I'm just going to call myself again with the style. I'm going to inject that into the token tree, and then I'm going to take the remaining tokens and I'm going to pass it to myself. So you can imagine the next thing is going to be BG color, because that's the last thing I think that's left. So here we just say BG color, and here we're going to say BG color some C, and then so basically now we call ourselves again, but essentially like there aren't any like there's nowhere left to go. We've like consumed all the tokens. There's nothing left. So when do we stop this recursion? So when we stop the recursion is say, okay, if you just pass me like a style with nothing else, then I'm going to stop the recursion basically. So let's see, semicolons here, and then there you go. So basically now I forgot to put semicolons. Otherwise it was returning this. So essentially like now it's saying, okay, I know how to handle bold. I know how to handle italic, underline. And if I see bold, italic, underline, I'm just going to keep consuming them. And then I'm going to call myself, is that helper macro with the remainder of the tokens. And I'm just going to, now let's see if this works. So let's see, where's our test? Pretty sure I had a test here. Where'd the test go? Ah, here it is. Okay, so we do, this test does compile, so that's good news. Let's just do this. Let's see what the heck is going on with style. Why is there? Okay, so this is why I had a CFG test, because of this. But what's happening is that because of this condition, because of this, the tests are not compiled as part of the binary that is not the test. So the target tests are compiled as separate binaries in your target folder. So what this is saying is that, okay, the non-test code doesn't use color, which is correct. The test code uses color. So that's why I usually have this CFG test. And here, let's say mod tests and something like that. And then now when I do an import here, because it's inside of this this flag, this code will only compile for tests, and then I can safely remove this, and it won't keep complaining. There you go. So let's see what this this test looks like. It goes, oh, actually, it looks like something. So let's properly format it. I keep forgetting which one. Oh, there we go. Okay, so we got bold, we got some value of bold, we got italic, some value of italic, and we got the foreground background color. So that totally worked. So here I can say assert EQ that yes, it should have bold, it should have italic, it should have underline, foreground color, background color, and oh, look at that. Because we used the new type pattern, it caught the error of the that the AI thing was making. That's so cool. So yeah, totally good idea to let's see, underline, to use new types. They seem kind of redundant, except for when you see how many mistakes are just avoided, you know, because of that reason. So oh, I see. It moved it. Oops. Let's do this. Where's our color struct? Let's do this. Let's make it copy and clone. So now we gotta make all of these copy and clone. That's fine. Copy, clone. Okay. So now it'll just be copied. Okay. So now if we do begin next test, yay, all works. So that kind of went pretty fast. Like, but yeah, that's essentially the magic of using the token tree and having a helper macro. So this is the main macro and the recursively called helper macro. It's the main macro. You can think of it this way: for setup, for setting up a new style, and this is helper macro that's called recursively to apply various attributes to the style. So now, so you can think of it this way. This is our expected syntax. Like that's just one expected syntax, right? We could have many. So let's do another one where we let's do this. Let's do pink. Let's keep these outside, and then let's do another one where we say something like the style is going to be new style, and I'm not going to have the let's say it's just going to be bold, and I'm only going to set a foreground color. I'm not going to set a background color. So something along these lines. Notice this works because that's how we set up the helper macro. And so it's just basically recursion. Like match this first. These are the highest priority, you know, and that's the lowest priority. So base case, this is the, let's just say base case to stop recursion. Yeah, and something like that. Essentially, it's like actually I could have just done this. There's no need. Actually, can I do this? No. So this is base case to stop recursing, and basically when no more tokens are left. And then let's see, certq. Let's see. So this one. Oops, what is happening? Okay. So assert that there's no italic, there's no underline, assert that the foreground color, and yeah, there you go. And that test, look at that, passes. So there you go. So far we have like the, actually I kind of did this example first. Where did it go? I think I did it the other way. Yeah. I'm gonna put this, the reason I'm putting these here is because I'll share this with in the description of the video. Also, we have a Discord. Like I disable comments in videos because people say mean things sometimes, or some people say mean things, and it's just easy for me to disable them, and that way I don't get to see the mean things. So if you do want to share feedback, we have a Discord that you can. Let me show it to you here. We have a Discord, so please, provide comments, feedback on the Discord, And also I put show notes on the Discord, detailed stuff that I can't put in the YouTube description, so that's a good place to check it out. Also, if you like this video, please do subscribe, so you can be notified when new videos, I add new videos. Let's see, where are we? I think that was it. That was the new style and apply style. And let me just quickly add this. Okay, so now we are done with the second example, and let us proceed to the third one. So the third one, the fourth one, are the third one is going to use the token tree, but in a slightly different way. And the fourth one is actually going to be using something called paste, so which is a very different example than the second two. Okay. So in this next example, I'm actually gonna do something that uses the format args. This is actually a very interesting use case where I'm gonna do a video on this at some point. I'm in the rewrite of the Rebel TUI repo. I'm using a lot of inline strings and inline vecs. They're basically small vec and small string, and there's some a lot of things, considerations for memory, latency, locality, and size that had to be taken into account. So I ended up having to make this macro, which kind of mimicked how format and println work, but I wanted to use format and println. So I ended up with this thing, and I'll explain like in this example like what the rationale was and what it even does. So let me do the boilerplate setup of this and create an example 3. So in example 3, let's do the CFG test, because why not? Mod test. So the expected syntax that I am looking for is something along these lines. So I have a, let's say I have a collection, and let's see, so that collection will be something like, I have items 1, 2, 3, and I want to either comma delimit or something, like essentially do items dot join, something like that. But I want it, but I want this to, like, this will return a string. But I don't want to return a string. I want to use the, let's say, the display trait to actually write the comma delimited items into some other struct that is not a string. Like how do I go about that? And there's a reason for this, is that I had to basically, instead of string, I could write to anything that has the implements the right trait. So it made it incredibly flexible. So I could write to like statically allocated array if I knew like the size up front. So I can add up 1, 2, 3 and like 2 commas, and then now I know exactly how much memory to allocate on the stack, and then I can write this items array into that thing. So the macro is going to be called, let's see, this is joint, let's just call it joined items, and then the code is going to be something like let expected, so that's actually, let's call these expected, and the macro is going to be result, which is going to be, we're going to call it join FMT, which doesn't exist, and join FMT is going to take something called format, and format is going to be the thing inside of which I wanted to write the output. So I'm going to say let mute accumulator is new, and I'm going to say the format is accumulator, the items is items, the separator is comma, same thing here. And then actually, let's see, from, just do this, from items, actually, oh, and then each is like, Why do we need each? We're gonna be extracting, how to put this, like we're gonna be extracting. It's kind of like it's almost like a meta argument where the join format will like when we implement the macro, there's going to be a loop which is going to loop over all the items in the collection, and then this essentially is it's actually not necessary, but it's to add like one more layer of complexity, which it's kind of like if you wanted, like for example, let's say that you didn't want to just do a toString, but you wanted to extract some other, you wanted to apply some other transformation to that type, then you would need to essentially specify like, okay, what do I name what identifier do I give to each item, and then I am going to specify like how to format that item. So let's just call this item for now. This is my explanation is not at all clear, and it's probably more confusing. So let's do this delimiter. So this is what I'm talking about. So the format, let's say format item. This is going to be something like, typically it would just be item to string, but I am going to do something like this. I'm going to say I want this is typically what would go inside of the format macro. So we'll see how this where this makes sense in just a minute. Like you could do all kinds of interesting things for formatting each item in this collection. So let's see. Let us implement this macro. So this is going to be something like, what is this macro export? And we're going to say something like macro rules join format. And okay, so this is like, what are the let's see, like what are the different pieces that we need. So the first thing we said was format, so we give it, okay, if you give me format, let's just say it's an expression, then actually FMT is not a good word. I'm going to call this accumulator. It's the thing that we're going to write to. So, or we can say write, maybe. I don't know, we can play with language later. So from is the collection, and that's like something like that. Actually, then we have each, and each is an identifier that we've just made up basically for the, it's like an identifier we're passing to the macro that we're going to be in our loop over the collection. We're going to be assigning each item. We're going to be referencing each item or whatever it is. Like we're going to use a symbol to essentially to do some, apply this formatter on this identifier. And that's just a delimiter. So actually, why don't we put the delimiter here? Because that might make more. So the delimiter is going to be an expression. So we got from, we got each, and the final item is the format item, which is just going to be a token tree. So there you go. That's essentially the setup for all of this. And so now when we go to implement this, it looks something like this. So let's make a, we're going to make a iterator given the collection, and we're going to make it mutable. Then we're going to handle the first item. So if you think about the logic, the first item we can pull out, if there's only one item, it doesn't need delimiters. But if there's more than one item, then what we can do is loop through the remaining tokens and always inject a comma or whatever the delimiter is. So this is remaining items. So first item is going to be something like if let some item, so whatever, we just, because it's an iterator, we're like, okay. And then here, actually this is fine, right? Format, we're going to do, instead of unwrap, we're just going to do like this. Like, we don't really care. So basically what this is saying is that write, using the write macro, this thing implements write. Take the, this thing and write it to format. So it's kind of starting to accumulate. That's why I wanted to call it accumulator, because it's accumulating those results. So what's the problem here? Oh yeah, right. So before you can use, this is somewhat annoying, you can say use standard format, right? As, so basically what this is saying is that I don't know what a write is, because this macro, you need to import this in order for this to work. Okay, so okay, so there's our required import to be able to write anything. So we're basically saying, all right, we're gonna, the format item is like a template. So you give it like the first item, you give it to the template, and it will write it into the accumulator. So here, if I want, I can just say, I don't like FMT, so I'll say accumulator. And instead of write, we can just say maybe write to, or write into, or something like that. Yeah, let's do this, write into. Yeah, there we go. Okay, so we're gonna write into the accumulator. Here's the delimiter for there's more than one item. From, I actually don't like from anymore. I'm gonna use items, and the collection, I don't like collections anymore. Let's just use items. And then notice that this items and that items have nothing to do with each other. This is just this thing, items colon. It's just a pattern matcher. So maybe I should have not called, let's call it collections then. Okay, so the delimiter, but then I'm calling this delimiter. You know what? Let's call it separator. So right into the accumulator, separator, collection, item, and format item. Okay, so that didn't break anything. So for the remaining items, what we're going to do is for each item, we're going to write the separator first. Then we're going to basically stamp the remaining item, because it's happening in a loop. We're just going to keep stamping it. So you'll see this, like, basically it's happening twice, so to speak. And then roughly this is how we end up with this result. So here, if we do print line, what the heck, print line, print line result. Why is this not working? Oh boy. Let's see. Okay. Right, there's no need for let binding because it doesn't return anything. That is correct. Because we're just, I guess we could return the accumulator. But there would be no point because we already have access to it. So unless we want to move it, it doesn't matter. Or we could do something like this. We could say, where's the accumulator? So let's say we return accumulator. We would say accumulator, and then we could do something like this. We just like, all right, just give me the string, and I will something like that. I mean, I don't know. That's another way of doing it. Okay, so let's see if this works. That did not work. Let's see, right into, what is this? Where am I writing into accumulator? Here, and I'm returning the accumulator, okay. Collection.iter, right into, where's right into? Okay, let's expand the macro and see what happens. So here we have, so we have, so it does the import, it takes items and it gets the iterator. Oh no, see the problem? No wonder it's unit. Okay, so that's not gonna work. We need to have this is why it's really, really, really important to, there we go. I guess in that case, what we would have to do is, I guess, create the accumulator here. So yeah, I kind of wrap myself around that axle. So let's just do this. This will, yeah, it will not return the accumulator. It will just leave it. Actually, we could return the accumulator, but I don't see the point of that because now we're passing it and we're getting it back. So that's just confusing. Let's just do this. There we go. Because we already have the accumulator here. So now if we expand the macro, let's see. We have, okay, you take the items, you get the iterator out of it. You say, if this is essentially first, if there's something, then say core format args, and then that's the whatever the format args, and okay, it seems okay because it's using accumulator.write, so that's good. So notice that's how write itself gets expanded. So if we run it, oh, it's still unit. What? I think I must be doing something wrong with this. Let's see. Format. Okay, so we got from items, each item, delimiter is a comma. Okay. Oh. Let's see, accumulator, separator. Let's see what this token is. Let's see, where's this expansion? Okay. It is, actually, can we do, why doesn't it put it underneath? There we go. So here we go. Let's see. So the first loop is if let some item is next, okay, then accumulator.writeFMT format args, and then single tick. Oh, what the heck? In quote, single tick. Wonder if that's the issue. Let's expand the macro again. Okay, now it's just item, and it knows what item is because that's defined here. Okay. Oh my goodness. Oh boy. That was kind of sad. So, okay, at least like that. There is no reason for, I don't know why there was this tick in here. That doesn't make any. I guess if we wanted to, okay, I know why that tick was there. Okay, so all right, so there we go. So that's working. It helps to print line the right thing. So this is working. And here we can say assert accumulators expected, and that should work. Oops, what the heck, cargo? No, bacon. Nope, there we go. Yeah, so that works. What the heck? Unused imports. Why is it complaining? Okay. Okay, so all the tests are passing, and that worked. Where's example 3? So here, let's take a look at this real quick. So let's say I wanted to do a different example, right? So this example is pretty straightforward. But why have all this super complicated formatting logic? Like, why am I passing item here and then a formatter for that item here? Like, what was the purpose for that unnecessary, seemingly unnecessary complication? So let's say I want to do something different, where I want to say something like, I want to do something like this. Actually, let's put this as a separate test. We're going to call this FN custom item format. This is to demonstrate like why even have this complication in the first place. It was like a little bit complicated, but there is actually a win that happens. So okay. So by the way, even though I'm using string here, I could use anything that implements right. So that could be an inline string. It could be an inline vec of U8s. It could be some other struct that I have. Like in the 2E, there's this concept of input device and output device. It could be an output device abstract standard out. And it's asynchronous. It can be tested. It can be paused. So there's all kinds of interesting things that that can implement right. So so here, let's say I want to put a backtick around each item. That's what this was. So now when I print it, you're going to see a bunch of backticks around each item. See, 1, 2, 3. So it's not just 1, 2, 3 anymore. So if I print like this previous one, you'll see that's just 1, 2, 3. No, no single ticks. But when I put because I have a custom formatter, I can do this, or I can say something like this. I can put greater than, and now every item will have that. Or I can do something like this. I can put \n at the end of it. So something along those lines. And so this is like, so as you can see, actually this is terrible. Let's just do this like that. And so you can see like 1, 2, 3. And then if I wanted, I could put the delimiter as like new line or something like that. So the reason it's not printing this is because of this. So if I do, see, so now it's gonna just display it rather than showing all the debug output. So this is the kind of stuff that I can do with the item formatter. So so there you go. That's the essentially using the token tree and also leveraging an existing macro which also uses token tree, which is like write, print, write line, print line, format args. So this is kind of like you can take what's already there and kind of add your own flavor to it. So if we look at the macro expansion, notice what that looks like, which is so essentially like that. So where even the write macro gets expanded to this thing, which is then also a call to format args. That's another macro. So it's like macros upon macros upon macros. So that's pretty cool. All right, so that yeah, that works with that. I think we have finished example 3, and there's one last example left, which is demonstrating the use of paste macro, which itself is a macro. So yeah, let's do that next. So in this final example, we're going to use the paste macro to do something to kind of expand on the capabilities of the default macros, declarative macros in Rust. And let's see. So what we're going to do is, it's a bit of a contrived example, but we're going to create a struct, which is just a normal struct, and then we're going to create an impl block for the struct where we're going to create a method where we're going to pass the name of that method to the macro. So this is something that you can't normally do. So like here's a little bit of an explanation. Like standard declarative macros can only substitute tokens. They can create new identifiers by combining or modifying existing ones. So basically, if you wanted to make something new, like a new method name based on an existing one, you can't do that. You can only just basically you can either, whatever's there, that's what you got to use. So that's so again, it's a bit of a made up example, but so here's like let's do this with let's have a struct called myStruct, and that just wraps the usize, so nothing really interesting going on there. And then actually let's put this in a test, fn test. Okay, so let's say we have a struct, and what we want to do is we want to create a impl block for this struct. So we say it like this, and this is going to use just regular declarative macro syntax, not anything special. So here we can see I can just say, let's see, this is the name, this is type, and this is the struct name, something like that. So struct name. Okay, so we have something like that. And so now we can just say instance new, because that's this macro actually generated this code. And that should be 0. So we can say, and let's see if that works. Oops, okay, so that works. So if I run this, that's fine. Okay, so this is like pretty mundane stuff. So, but what if I wanted to make a method, and like I want to pass the name of the method, and I want to like sort of modify that method? Because if you look at the standard declarative macros can only substitute tokens. They cannot create new identifiers by combining or modifying existing ones. So yeah, so they have the ability to manipulate identifiers like struct names and function names during macro expansion. So let's see. So maybe what I can say is that let's say I want to make a different one. Actually, let's see. Can you use paste? Make me a macro that takes an identifier. Let's say, for example, method, and adds a prefix like to it. So this is the kind of stuff that you can't normally do. So let's try this. Oops, what the heck? Where'd it go? Okay, I want to copy this. Okay, so let's do that. Okay. So check this out. So here, there's the invocation of paste. So it's when I say add, actually, create method with add with prefix. So so here I can say So the name of this, let's call it the method name. So we can say something like, struct name is the type, and the method name is the identifier. So we can do something like this. We can say impl struct name, and then we can put like that. Yeah, something along these lines. I mean, this is completely made up, but it kind of, so like this right there is the thing that paste can do, where I can make a function. So let's say now I say create method with prefix, and I'm going to call it bar. So the thing that it's we're gonna see like a foo bar basically. So we're gonna say my struct.foobar, and that should actually, let's say print line. Let's just have it return a string, and instead of doing this, we can just say format. So here we can say let result, and we can print line the result to see what it did. So foo dollar name. Okay, why method name? Oh, oops. Method name. Let's run that again. Yeah. So this is so in Java they have these things called like introspection and reflection and stuff like that. So this is it's not really related to that, but it kind of reminds me, it's got a flavor of that, where like I have a struct, and because I can just keep adding nipple blocks to an existing struct, or even a struct that I haven't created. Like maybe there's certain things I want to sort of boilerplate, and I don't want to write those methods by hand, but I want to, like for example, name those methods a certain thing, but that name has to be derived. It cannot be literally just passed in like that. So this is like kind of like an example of where we can use paste to essentially like take something and then instead of just substituting a token, we're actually combining or modifying existing ones, because we want to come up with names that we don't just want to pass in, if that makes sense. So this is like a totally contrived example, but yeah, this is there are reasons for doing this. Like if you look at the singleton, I have a macro in the Rebel Open Core, which basically, given a struct, it makes it a global singleton, which is safe. Basically wraps it in an arc mutex, but you can, when you create this thing, you can let's see, it has to create a static variable, and the name of that static variable, it can't be whatever identifier you gave it. It has to be like once underscore prefix for just convention. And so that's an example of where this comes in handy, because I want to derive the like, so I can name my global variable global my struct, but under the hood there's got to be like an actual static variable, and so instead of just I can't call it global my struct. So just because I wanted to like put let's see. So if you look at this, my struct goes into, yeah, it just basically puts once underscore in front of global variable name. So actually, if I show you the code on this screen, it might make more sense. So here what it does is that it takes a type, and this is the name that you give it as an identifier, but then it actually generates essentially a name that's derived from the name that you gave it. I mean, yeah, I guess technically I could just call it once underscore global my struct here, but I don't know, I guess I wanted to use paste. One other really good thing about paste is this thing. you can have it generate documentation. So like, let's say that you have a function like this, right? And you want to make it like generate some docs for it. You can say something like, this is generated doc for the method foo underscore, and I think you can even give it like this, stringify. Yes, you can do something like this. Foo underscore. So you can say, let me do this again. Okay, so you can say stringify, so you can say method, this one is foo underscore, and then method name is generated by macro. Something like that. Makes no sense, but you can see like the let's see. I think when we do the Rust document generation, that should show up. If we did like cargo doc no deps, let's see. There's a cargo doc open. Which symbol is this? Oh, it's in a test. Ugh. Yeah, it's not gonna do anything because it's in a test, so it's gotten compiled out of the cargo docs. But what I could do is maybe make a pubfn main, for lack of a better reason, and then let's try this. Some ridiculous name. Maybe this will do it. Cargo doc. No. Top level. Oh, never mind. Because this needs to be at the top level as well. So let's see. Move the impl block outside of the function top level function. Oh, right. Then we can do this. Maybe this will work. Let's see. There's this thing called mystruct. No, mystruct. Yeah, there you go. Method foobar is generate. Wow, it's not a. It's made up example, but you can see where this might be useful. So basically, foo. I forgot the space. So there you go. Let's do this again. Cargo doc, and there you go. So method foobar is generated by the macro. So essentially, like the bar is. Where is it? The bar is what I supplied as an identifier, and the foo is what it prefixed it with for reasons, because we can't with paste and we can't with normal Rust declarative macros. And then I created a documentation, a doc comment for it, which shows up here, which is pretty cool. Like you can see if you use you know, declarative macros a lot, this is totally handy. Let's see if it shows up in VS Code. No, it doesn't. Which kind of makes sense because yeah, that would be kind of cool actually if it showed up here, like if foobar. Because I think, where'd it go? Yeah, because foobar here has the documentation, but when you look at this here, it doesn't. Also, when I control click on foobar, it just takes me to the macro. So that's, let's see if I can expand. No. Anyway, I guess that would be here. Yeah, expand. Let's see what that looks like. Foobar. Oh, it does have a dot comment in there. That's cool. But yeah, anyway. So there you go. That is fun with declarative macros for all kinds of interesting reasons. Some that may make sense. Some that don't make particular sense in this last example because it's kind of made up. But there are reasons, like for example, that global singleton, where I wanted to name something, and that name had to be derived from a token that I'm passing to the declarative macro. And also, I wanted to generate doc comments. So that was another requirement. So there you go. That's fun with declarative macros. Like I said, I've replaced procedural macros for that styling stuff in the Rebel 2e crate. This one with uh, the procedural macros I've replaced with the declarative macros, and it actually helped me clean up my crate structure as well. So this mono repo used to have like way too many crates. Now it has like 2 crates, I think, or 3 crates, which is kind of like where it's that makes sense. So yeah, if you like this stylus video, please give it a thumbs up and subscribe. And also, if you want to share feedback and comments on this or any other videos, we have our Discord channel. I turn off YouTube comments, so because some people are unkind, and that's the easiest way for me to avoid seeing those comments. But yeah, feel free to join the Discord if you want to check out show notes, which whatever stuff doesn't fit in the YouTube video description, I'll put it in there as well. And yeah, I have a couple more interesting videos. There's one big one on memory latency, locality, and size that I've been working on for a while, and a whole host of others. So thank you for watching, and have a great day.